Math 2134, coming to you from the College of DuPage, and this is the conclusion of the lecture entitled Limit Definition of the Derivative. When we ended last time, I posed this problem and you worked on it. I'm going to give you another opportunity in case you didn't finish. You know what to do. Let's see how you did. So we wanted to find f prime. We used the 4 steps. So we say, what is f of x plus h? So we're taking x plus h and we're plugging it in everywhere the x is up here. So we get x plus h whole squared minus 4 times parentheses x plus h. So that's minus, and we do algebra simplifying this. And then we subtract off f of x. Notice that we're subtracting off the whole of f of x. So it is minus x squared minus 4x. So we do all of the algebra again. You see there's a lot of algebra in calculus. And I get this. I do factor out the h because I am going to be taking limits in just a moment. So then I look at this difference quotient. The h's will cancel. So it simplifies to this. Then I'll take the limit as h goes to 0. This is 2x minus 4. Now they ask where is this slope equal to 0? Well, the tangent line is the slope. The slope of the tangent line is the derivative. And so when is 2x minus 4 equal to 0? And you say that's when x is equal to 2. They ask you to graph it. We graph it here, and we see the tangent line does have a slope of 0. The equation is y equal minus 4. And that means the rate of change is 0. Now here you see the slope of the tangent line will be negative. Here it becomes positive, so there it's changing from positive to negative, meaning it at that instant is 0. Here's another problem for you to do. This is y equals f of x equal 1 over x. You find f prime, find the slope of the tangent line at a given point, and then you find the equation of the tangent line. This is a very standard problem. I'm sure there'll be problems like this later in the course on the midterms and finals. You know what to do. Let's see how you did. Okay, we use the 4-step process again. So we plug in x plus h instead of x. We get 1 over x plus h. Then we subtract off the whole of f of x. So we have this minus this. Now, we have to get a common denominator. You see, we need to use algebra. You can't just plug h equal to 0 in here because you would get 0. So you get a common denominator. The common denominator is going to be the product of this. When we do that, we're going to get x minus parentheses x plus h. Make sure you understand this algebra over x plus h. When you distribute and simplify, you get h over this. But now you're going to take this and divide it by h, and forming the difference quotient. And you see those two h's are going to cancel. So you get 1 over x times x plus h. Then we take the limit as h goes to 0. And that's going to be 1 over x squared, because x plus h as h goes to 0 is just going to be x. So it's x times x is 1 over x squared. When I plug in x equal 1 into that, actually that is a minus 1 over x squared. Excuse me. Yeah, that is minus 1 over x squared. When I plug that in, I will get minus 1. And you see there's a minus sign there that you really can't see. So it's minus 1 over x squared. Okay, so this is, when you plug in x equal 1, you get f prime of 1 is equal to minus 1. And then the tangent line is going to be y minus the y coordinate is equal to the slope, minus 1 times x minus the x coordinate. We simplify that, and this is what we get for that in slope-intercept form. Here's another problem. We're talking about the velocity of the car. Here is the position of the car. You're to calculate the average velocity over some of these intervals, get the instantaneous velocity when t equal 22, and compare the results obtained in A with those in part B. You know what to do. Let's see how you did. Okay, so the average velocity over all of these intervals is going to be just the difference quotient. That's the average. And we get 4t plus 2h. and h has various values at these points. And so what you're going to get is that at these intervals you're going to get 88.2 and 88.02, and you see it's getting closer and closer to 88. And then what you're going to do is you're going to take the limit as h goes to 0. Now the limit as h goes to 0 of this difference quotient is going to be 4 times t. So then when we plug that in, we'll get 4 times 22. And so that says that the velocity at that instant is 88 feet per second at the instant when t is equal to 22. Remember that velocity is the first derivative with respect to time of position. That's a takeaway. Here's an applied problem number 7. You've got a demand for tires. You want to find the average rate of change for these quantities and then find what is the instantaneous rate of change of the unit price when the quantity demanded is 500 units. You know what to do. Let's see how you did. So the average rate of change is going to be the difference quotient. So we take f of x plus h, we're putting x plus h in everywhere where x was into this equation, minus the whole of f of x. So minus the whole of f of x, those parentheses are important. You get a different answer if you don't use the parentheses, and it would be wrong, over h. So we simplify this. There's quite a bit of algebra. Make sure you can replicate the algebra. The x squareds will cancel, and you can factor an h out, and after you do the simplification, you're going to get minus 2x minus h. So for the interval that they were talking about up here, h would be 1, and so we get minus 11. Now that means minus 11 times 1,000, because as units are in thousands. So that means that it's going to be the average rate of change between those are going to be this and that per 1,000 tires respectively. If you take the limit as h goes to 0, finding the derivative or the slope of the tangent line or the instantaneous rate of change, you'll get minus 2x, and so you can plug in what happens when it's 5,000, and you'll get minus $10 per 1,000 tires. There are many other applications, and always what will happen is that you have average rates of change are going to be the difference quotient, and instantaneous rates of change are going to be the derivatives. And it might be concentrations of drugs, it might be revenues, it might be volumes of sale, population, or amount of product formed in a chemical reaction, and many more. A lot of applications to this. There also is a relationship between differentiability and continuity. You can see this curve here is continuous because I can draw it without ever lifting my chalk. But when I think about the tangent lines are being positive here, and they're being negative over here. That means this abrupt change in direction here means the derivative is not going to exist there. Similarly, this curve has a vertical one. That means the slope is undefined at that point. So here's an example. So this woman is paid something if she works between 0 and 8 hours, and if she does overtime, this is what she gets paid. And so that's her earnings. She worked X hours. Then you want to sketch the graph and explain why it's not differentiable at x equal 8. You know what to do. Let's see how you did. Well, here's the picture, and you see there's an abrupt change of direction that happens there. The slope going up this far is just going to be 8. The slope up here is 12. There's an abrupt change in direction, and that's why this is not differentiable at that point. However, we do have a theorem. It's not proved here, but if a function is differentiable at x equal a, then it is continuous at x equal a. But as the previous example and discussion illustrates, the converse is not true. A function that is continuous at a point need not be differentiable. Think about this. And do now problem 9. So what you're supposed to do is at each of these points A, B, C, D, E, and F, you're supposed to explain why the function fails to be differentiable at each of those numbers. You know what to do. Let's see how you did. Okay, it's discontinuous at A, B, and C, and that means that it can't be differentiable. There's a kink at each of these points. They call it a kink at these points corresponding to these numbers. Let's just see what that means. D, oh, it's an abrupt change in direction. And finally, it's not differentiable at G because it ends up being a vertical line. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.